So chapter number 13, probability. So if we talk about whatever we study in the class 10, so we know that the probability of any event is always will be 0, greater than 0, but it is always less than or equals to 1. So that means probability lies between 0 and 1. The next one is probability of happening event plus probability of not happening event is denoted by E bar. So that can be 1. ये दो फॉर्मूले हमने 10th में पढ़े थे. Give first heading conditional probability. In conditional probability, that means we have given two event. हमें क्या किया होगा कि E और F दो events होंगे. At the time E is happening, F is not happening. Means हमें E find करना है जब F given हो और F find करना जब E given हो. So for example अगर मैं ऐसा लिखता हूँ P of E F means we have to find the probability of E when F is given. Or if I write like this, that means we have to find the probability of F when E is given. And the proper definition is this one for the conditional probability. According to that, a conditional probability of an event E given that F means we have to find E when F is given or F is occurred. यानी F हो रहा है तब हमें E find करना है. That means the probability of event E with respect to F. So we have the formula P of E given F is equals to P of E intersection F, or you can also write F intersection E upon given. Then the second is P of F given E. So P of E intersection F upon P of E when E is given. Okay, so first question is, given that E and F are the events such that P of E. So we have given P of E is equals to 0.6, P of F 0.3 and P of E intersection F. Now we have to find the P of E when F is occurred or F is given. So formula will be P of E intersection F upon second part, occurred part. So P of F. Now substitute the value. So it's 0.2 upon, it's not a E, F is given, na? So denominator will be F. So 0.2 upon P of F means 0.3. So it's a 2 by 3. So you can write 0.666. So approximately 0.67. Okay. So next we have to find F when E is occurred. So we'll write the formula intersection upon P of E this time. So 0.2 upon 0.6. So it will be 1 by 3.
Yes, sir. 1/3.
3, 3. So for first part, P of A intersection B. So P of B given A can be written as P of A intersection B upon P of A. Now substitute the value. P of B given A is 0.4. Intersection we have to find. P of A is 0.8. So A intersection B will be 0.4 into 0.8. So 32. So 0.32.
Yes, sir.
Okay, for the third part, P of A union B. So we have the formula A union B is equals to P of A
Plus P of B minus P of A intersection B.
A intersection B. Union is plus 0.5 minus 0.32. So it's a 1.3 minus 0.32.
0.98.
0.98 is the
9/8.
final. So in question number 4, from this part, we can write here twice P of A
11/26, sir.
Okay. So when we are writing the P of A, we can write 5 by 13 into 2. So it's a 5 by 26. 5 by 13. Now we have to find the P of A union B. So we have the formula P of A union B is equals to P of A plus P of B minus A intersection B. Now these two part is already given. This part is missing. So first we will find the P of A intersection B. For this part we will use A given B upon P of B. So P of A given B is 2 by 5. Intersection is missing and the P of B is 0, that is 5 by 13. So when we cross multiply it, it becomes 13 by 5 of P of A intersection B. So 2 into 5 upon 5 into 13. A
2 by
intersection
30.
2 by 13. So we can directly use P of A intersection B 2 by 13 in this part. So P of A 5 by 26, 5 by 13, that's a 2 by 13. So 5 by 26 and 3 by 13. So
11 upon 26.
okay, 5 plus 6, 11 by 26. So total sample space in case of coin is 2 raised to n, where n is number of toss. So 2 raised to 3, 8 sample space. So we can write S is equals to H H H H H T H T T TT. Okay. Then THH, TTH, STH, THT. So 3, 4, 5, 6, 7, 8. All 8 sample spaces are completed. Now the first question is E, that the probability of E that denote the head on 3 tosses. So E can be only HHH, head on third toss. So that means the third should be H. So third H means H, H, H. थर्ड पोजीशन पे H होना चाहिए. So ये 1 हो गया, ये 2 हो गया, ये
THH,
3 हो गया
3,
और ये
4.
4. So E contain 4 sample space, 4 out of 8 sample space. So THH,
by
TTH, 1, 2, 3, and the last one is STH. HTH. Now F is head on first 2 toss. So head on first 2 toss. So
6
1, 2,
possibilities.
2 possibility, right?
1/4.
So HH, T. These are 2 possibility for the head on first toss. Now we have given that
No
find
sir.
the intersection of PA. We will
सर
find
F में तो F में 6 पॉसिबिलिटीज आएंगी.
the F में 6 possibility क्यों आएगी?
सर फर्स्ट 2 में से कोई भी एक भी होगा तो भी चलेगा ना.
और E intersection है. E
HHH.
having H, H, H. Now find the probability of fall. P of E that is
1/2.
of 8. P of F that is
1/4.
1 by 4. P of E intersection F.
1/8.
Now we have to find P of E given F. First one we have to find, then the second one is already occurred. So F is occurred. So P of F 1 by 8. It's a 1 by 4.
1/2.
So final answer is 1 by 2. So we have given value of E R 1, 3, 5. F 2, 3 and G 2, 3, 4 and 5. So before calculating all this, let's find the fair dice tosses. So its sample space will be 1 to 6. Then we will find first P of E. That is 3 number out of 6. So 1 by 2. Then P of F. That is 2 number out of 6. So it's a 1 by 3. Then let's find E intersection F. So there is a 3 common. Then we can also find here E union F. So in E union F, we have number 1, 2, 3, 5. Now suppose you want to find the probability of E intersection F. So we can write here P of E intersection F is equals to one number out of 6. Similarly, if you need to find the P of E union F, you can write here it contains 4 number out of 6. So it's a 2 by 3. Question number 1 and 2. In 11 question, you can solve by using the above equation. That means we have already used in question number 3, 5. Here I am going to solve question number 3. So in question number 3, first we need to find, okay, if we write the formula for the P of E union F given G. So here P of E union F, then U intersection with G, this upon P of G. So these are the additional calculation for the E union F and with the intersection of G. So now these three elements are common in both the part. So it means we will write the 2, 3 and 5. Now we need a probability. So for finding the probability, now if we compare the probability of E union F with the intersection G, we have 3 element out of 6 element. So its probability will be 1 by 2. Now substitute all these 3 value in this equation. So we have that the union with the intersection is 2 by 3 and not 2 by 3, it's a 1 by 2. So 1 by 2, then probability of G is 2 by 3. Now if you see the probability of G, that having the here 4 element out of 6, so G will be 4 by 6, so that will be probability of G is 2 by 3. Now we are using here 2 by 3, so we can directly write 2 by 3 into 3 by 2. So its a final answer will be 3 by 4. Now we know that the probability is always less than 1, so that's why we are getting the denominator greater than the numerator. Okay, now see the second part that we have to find with the P of probability of E intersection with the G. Now if we write the formula, it become E intersection F. It is not a F, it is G. G with the again intersection G and given probability of G. So before finding this, we need to find the E intersection with the G. So let's calculate here E intersection with the G. So we'll get here 3 and 5. Now again we have to find E intersection with the G again with the G. So it having the common element again 3 and 5. So when we are going to calculate the probability of this, we can write here P of E intersection G will be 2 element out of 6. So it will be 1 by 3. So we can write here 1 by 3 upon P of G, that is 2 by 3. So final answer will be 1 by 3 into 3 by 2. So its answer will be 1 by 2. Now in the same way, suppose the question is given like P of E intersection F given G. So we'll write here P of E intersection F intersection G upon P of G. Now if we find the E intersection F, then we have E intersection F will be three. And now if you find the E intersection F with the intersection G, again we have only three element common. So we can write a probability of this will be 1 by 6, then there are 2 by 3. So 1 by 6 into 3 by 2. So it's a 3, 2 ja. So final probability will be 1 by 4.